Righteous. Excellent. Look at us go here. I'm a Hilu from the 403 to the HAZ. Where are my writing utensils? I just had them. Oh, this is so embarrassing. There they are. My little babies. My little babies. And my coffee. Holy crap. Okay. Hey, what is happening? Hazelton, Pre-Cal 12. What? Okay. In the last video, we just started solving trigonometric equations, and we kind of started with our first degree problem, so when we're not dealing with squared items. So that was the previous video. So what happens when we start to have squared terms in our problem? So for example, what if I had, what color do you guys want me to use? I think we're ready for some blue, aren't we? Okay, so let's say I had, this is straight from the textbook, and then I'll do some from the problems. Tan theta minus 5 tan theta plus 4, okay, is equal to 0. Okay, and I am trying to solve for theta, for my unknown angle. Now, and they also give me the restriction that this is for the domain from zero, basically a full circle from 0 to theta to 360 degrees, so for the entirety of the circle. So I'm not looking for like coterminals or 720 degrees. I'm just looking for in my first rotation, okay? So in order to solve this, I just gotta treat it like a trinomial. And like these are actually not so bad if we understand factoring trinomials, because I can basically say, okay, x is gonna be equal to tan theta. And then I could rewrite this as x squared minus 5x plus 4 is equal to 0. And I'm just gonna factor it the exact same way. So just think of tan theta, or your ratio theta, as your variable. So, well, basically, when I do that, in this case, I have no term in front of my squared term, so I can go straight and use the product sum method. So what are two numbers that multiply to positive 4 and add to a negative 5? Well, negative 4 times negative 1 makes positive 4, adds to negative 5. So I can factor this now, okay? When I factor it, it's going to look like this. Tan theta, what was it? Minus 1 times tan theta minus 4 is equal to 0. Just like if I were to say x minus 1, x minus 4 equals to 0. And then in this case, if I was to ask you what are my roots, what are my solutions, it would be x is equal to positive 1 and positive 4. So in the same way, my solutions here are that tan theta is equal to positive 1. Basically, I make each of these equal to 0. So I can divide this all out and make this equal to 0. So I'll do it. I don't like to leave you guys hanging. So if I was to actually figure out what my solutions are, there's two avenues. The first is, okay, I'm going to divide both sides by tan theta minus 4 to isolate this binomial, and in doing so, tan of theta minus 1 becomes equal to 0, because 0 divided by this is 0. So my first solution is tan of theta is equal to 1. To 1, okay? Which could be the same, we could write that as 1 over 1, because 1 over 1 is 1. Because we do know that this should be a ratio. Tan of theta should be a ratio. And then the other one is where tan theta minus 4, when I divide both sides by tan theta minus 1, instead, that's equal to 0. Therefore, tan theta is equal to 4 over 1, possibly. Okay, so now I have to figure out, okay, well, what angles of theta will give me this answer and this answer? This answer, I can tell, is going to be on my unit circle. This one, a 4 is way too big to be on my unit circle, so I'll probably have to use trigonometry to solve, or sorry, my calculator to solve this one. So where am I going to get a tan where basically my opposite and my adjacent are 1? Well, that's going to happen basically when I'm at the 45-degree angle, because a 45-degree angle creates an opposite and an adjacent that are the same length. That's why we get, for cos, we get 1 over root 2, because root 2 is my, root 2 becomes my hypotenuse, and 1 over root 2. So in this case, tan of theta gives me a theta of pi over 4. Okay, a positive pi over 4. It couldn't work here because I would get positive, I'd get a positive y but a negative x. So this would become negative here. Down here, if I was at a 45-degree reference angle from this line, this would give me a negative x, or a negative y, over a negative x. So in this case, this angle would actually also be potential, because they're saying from 0 all the way to 2 pi. So I have to consider this answer. And what angle do I get there? Well, it's going to be pi, where I'm starting here, plus 45 degrees, or pi over 4, which is 4 pi over 4, if I put this into a denominator with 4, plus pi over 4, which is 5 pi over 4. So that's another answer, is 5 pi over 4. Okay, those are 2 potential answers there, and that's for this answer here. And then the other one is at tan theta is equal to 4, which if I use tan inverse of 4, it'll give me theta, and it gives me 1.33. So theta is also equal to 1.33 radians, okay? Radians. So we know that if I had to be in quadrant 3 as well for this guy, then I'm going to have to do the same thing for this guy, because I'm going to get a positive tan over here as well. So basically I have to 1.33, I basically have to add, whoops. I basically have to add a pi. Okay, so the other answer is when I add pi to that. So it's going to be 1.33 plus pi is 4.47. Okay, this might seem really confusing right now. It's even confusing a little for me, but this is how we approach it. I don't like this component, I like this component. But let's just roll with it, go with it. It should kind of get more and more clear as we go. It's okay for it to be muddy at the beginning. So the most important thing is that we recognize that we can deal with them as a trinomial. Okay, getting down to this part, this is messy. And I would never give you something like this because it's confusing to go from working with pi to just working with straight radians. In any case, math is just about doing our best, okay? Sometimes if we're a boxer, we might have an awesome jab, and we might have like a weak uppercut, and that's okay. We can just work, keep developing our skills. We just do our best to become as good a fighter as we can, or as good a mathlete as we can. Okay, let's do another one. Okay. I'm going to do some from the book now. So, let's do 7a. Oh, they really don't like me here, right? Okay. 7a it is. Okay, so we have 2 cos squared theta minus 3 cos theta plus 1 is equal to 0, and they want to know from basically for one rotation, okay? One positive rotation. Okay, so we have a trinomial here. In this case, we have a number in front of our squared term, which is a good sign that if we know what we're doing factoring, we can't use product sum, so we can either just guess and test, which in this case wouldn't be so bad, or we can use decomposition. So let's use decomposition. If we recall, in decomposition we multiply the first, what do you call that? Coefficient with the last one. So we get 2. 2 times 1 is 2. So now I'm looking for two numbers that multiply to a positive 2 and add to a minus 3. And clearly those are negative 2 times negative 1. So now I'm going to replace my middle term as a sum of these two. So in doing so, I get, 2 cos squared theta minus 2. It doesn't matter what order I put them in, but one order will always factor nicer. Cos theta minus 1 cos theta, I'll put the 1 in there, plus 1 is equal to 0. And then I split them in half, and I'm going to factor this one. So I'm going to have 2 cos theta minus 1. Okay, I was able to pull out a 2 and a cos theta. And that's what I get there. Because I'm treating cos theta as just like an x, so I'm just doing the same thing. And then here, whatever's in brackets here is going to show up over here. And it's going to be cos theta minus 1. And therefore, in order to get minus 1 cos theta plus 1, I have to have a minus 1 here. Now this cos theta minus 1, I can replace with like a variable, let's say z. And in doing so, I could factor out a z, and then that's gonna, and then so if I factor out that, I get cos theta minus 1 times 2 cos theta to get this term, minus 1 to get this term here. Okay, so this is my solution, or where I can pull my solution from. So now I'm going to make each of these binomials equal to 0 to solve them. So I get, my first solution is going to be cos of theta is equal to 1. And cos of theta is equal to 1 over 2. Now, I am looking for all the solutions in this domain, right? So I have a cos theta that's positive. So let's do the first one here. Let's do cos theta equal to 1. When is cos theta equal to 1? Well, basically when my terminal arm is the entire x-axis there. Okay, so it's when it's right here. So that happens at theta is equal to 0. And because theta can be greater or equal to 0. So 0 is a good answer. And we were looking for positive 1. It doesn't happen here because this will be negative 1. So it'll happen at 0 and 2 pi. Okay, so it happens here and then back here because theta can be equal to 2 pi as well. So that's one solution. The other one is where cos theta is equal to a half. So where do I get cos theta of a half? Looks like right here. So when I'm at pi over 3, that means that I have, and my angle was right here, my cos would be right here, and that would be 1/2. That's my x-coordinate, which is cos theta. So it's 1/2. So that happens at theta is equal to pi over 3. And then where else am I going to get a positive 1/2? Well, it's going to happen in my positive x side. So it's going to happen basically down here as well. So when my theta here is pi over 3 from this as a reference angle there, basically I have to take 2 pi and subtract my reference angle to get where basically my angle over here. Okay, so I'm going to take 2 pi, I'm going to subtract pi over 3, and I get 6 pi over 3, using the same common denominator, minus pi over 3, is equal to 5 pi over 3. So my other answer is 5 pi over 3. And I'm going to check the answers in the book, because I don't trust myself. 212, okay, we're looking at 4, no, we're looking at 7a, and we got 0, pi over 3, 5 pi over 3. Oh, you know what, okay, and they actually, in the book, they said it has to be smaller than 2 pi, so this answer goes away. But all the other answers we had were correct. I took away the 2 pi because in the book it says it has to be greater or equal to pi, or 0, but it has to be smaller than 2 pi. So 2 pi as an answer is not viable because it's not smaller than 2 pi. It doesn't fall in that range. So here are the answers for this one. Okay, let's do another one. And I'm going to make sure I'm still filming. Hey! Hooray for me, baby! Hooray for me! Okay, Doyle rules. Okay, here we go. Okay, last one here. Secant squared theta minus 2 secant theta minus 3 equals 0. Okay, I got a trinomial. So, just to make it easier for me to see, x squared minus 2x minus 3 equals 0. Two numbers that make negative 3 that add to negative 2. Multiply to negative 3, add to negative 2 is negative 3 times positive 1. So factoring it, it would become x minus 3, x plus 1. And I basically made x equal to secant theta, so I can rewrite this as secant theta minus 3, secant theta plus 1 is equal to 0. And this is where I'm going to extract my solutions from. And I'm going to have to use this as well to help me out, because I only know the sine, cosine, and tangent ratios on this unit circle, so I would have to use that knowledge to figure out what secant is equal to. So let's do it. Let's work with this first one here. No, let's work with this one here, because this one's going to be nicer. Secant theta is equal to negative 1 from here. Okay, because secant theta plus 1 equals 0 if I divide out this side. And so secant theta is equal to negative 1. Okay? But this is not going to help me until I figure out what cos is equal to. Or what angle this would work out to with cos. So I know that cos, if secant is equal to 1 over cos, and I solved for cos theta, I'd multiply both sides by cos theta, divide by secant, so I know that cos theta is equal to 1 over secant theta. Okay, so, and cos theta is 1 over negative 1. So because I know that secant theta is equal to negative 1 here, so it's 1 over negative 1, which is negative 1 over 1. Or negative 1. So where do I get a cos theta of negative 1? Where is cos negative 1? cos theta is -1, an entire -1, here at pi. Therefore, theta for this one is equal to pi. And they actually gave me a restriction that we're going from -180 degrees, so we're going from here all the way to 180 degrees. That's the restriction. They said -180 to +180. Okay, so that's the first answer. Uh, 7D. Okay. So they actually had it from -180 degrees. So in this case, it has to be negative pi because they're going clockwise. But this, being able to get here is more important than this stuff up here. But we'll get there. Just confusing. Just deal with it. In any case, so it's negative pi or pi, depending on what our domain is. But essentially, we know that it's going to be this angle. Now because they wanted to start at -180 and not including all the way to 180, not inclusive. So only negative pi is a potential answer there. Okay, so here we go. Negative pi, or -180 degrees. And then our second solution is one that's not on the unit circle. It's a little bit bigger. So it's secant theta is equal to 3. Or sorry, secant theta minus 3 is equal to 0. Therefore, secant theta is equal to +3. And therefore, using this, cos theta is equal to 1 over secant theta, which is 3. So theta is equal to the cos inverse of 1 over 3. So cos inverse of 1/3 gives me 70 70.53 degrees, because my calculator is working in degrees right now. So 70.53 degrees is from -180. So 70.53 is up here. And then where else am I going to get a positive ratio? I'm going to get a positive ratio down here as well for cos. Cos is going to be positive over here as well. So I need to add this is embarrassing. I'm just terrible at math. We're going secant is equal to +3, 1 divided by 3, 1/3. Yeah, basically it's going to be 70.53 in the positive direction to get that ratio, but then the same thing coming down here, we got to go negative. So that's really confusing, and that's okay. These problems that I chose were kind of harder ones, okay? Just trying to do you guys honest here, okay? And I think that's all I'm going to do for now. And I'll come back once I realize that there's fires. Thanks, guys.